Hello everyone. In this video, we're going to continue right where we left off in our last video. In our last video, we wrote code that would open a file called transactions.txt for reading, check to make sure that the file was successfully opened or not. If it wasn't successfully opened, exit the program. And then lastly, it closed the input file. In this video, we're going to continue with our file processing template. We've opened, we've closed, now we need to process. So if you don't already have your fileio.fun.cpp and your transactions.txt open in Git, go ahead and open those now and make sure that you're still able to successfully open the input file. You'll know that you're successfully able to open the input file when you save, compile, and run. And you see successfully open the input file in your output. So our learning objectives for today: be able to read data from a file, write data to a file, and use a loop to read in data completely from a file, meaning from the beginning to the end of the file, without knowing in advance how many pieces of information or how many lines are in the file. That will make our programs really versatile because they'll be able to work with varying lengths files. All right, so we're going to start with reading. Now, one thing that's really cool about reading from a file is you already know how to do it. Reading from a file is just like reading from CIN, user input. I cannot emphasize this enough. So far in this course, you've been using CIN and the stream extraction operator, that's this guy, and getLine in order to get data from the user. You've been doing this the whole semester so far. And you've learned a lot about how CIN, the stream extraction operator, and getLine works. You know that if you start mixing CIN and getLine, or excuse me, stream extraction operator and getLine, you can get some weird behavior, right? We talked about the new line character and how tricky it can be in order to clear out from the buffer. Here I've just pasted some notes from the notes on using CIN, stream extraction operator, and getLine, where we talked in detail about how to work with white space characters and new line characters from user input. So take a moment and reread all of this information here, just to refresh yourself on how getting input from the user works. Now we're going to apply all of those same rules about how getting input from the user works to getting data or input from a file. In fact, the only thing that needs to change is instead of using CIN, we're going to use our ifstream object instead. That is it. It's actually really cool how slick this is going to work. All right, so transactions.txt has got a bunch of floating point values in it. Let's go ahead and declare a double called transaction, which we'll use to store a transaction that we read from the file. Now down here under step 2, process the file, let's read a single transaction from the file. And reading always starts from the beginning of the file. Now, if we were going to read a double value in from the user, we would type CIN, the stream extraction operator, and then the name of the variable where we want to store that value from the user, in this case, transaction. If instead we want to get the value from an input file, specifically transactions.txt, all we have to do is replace CIN with our ifstream variable, which is input file. That's it. That's all we have to do. Now let's just see out transaction, just so we can see the value that we read from the file. All right, it says we read in 12.45. If I head over to my transactions.txt, I see that in fact 12.45 is the first double value in the file. So that's really cool. So now I want you to go ahead and read the rest of the values from the file. You know how to read one value, so just repeat this and you should be able to read multiple values from the file. So there's two instincts you might have had to solve this problem. One would involve copying and pasting these two lines of code however many times there are remaining values in your file. That would work. When I said repeat, you might have thought, okay, let's put a loop in here. And that's the solution that I'm going to code up. So in my file, I know that there are 5 double values. 1, 2, 3, 4, 5. So I can just do this 5 times. I'll need to add a loop control variable I. I'll initialize it to 0. And I'll have I less than 5 and I plus plus. And there are my 5 values. Awesome, this is really cool. The only thing is, let's say I add another value to transactions.txt. And I go to run my program again. It's only going to read the first 5 values regardless of how many values are actually in the file because of this number right here. Ideally, what we would like to do is be able to read from the file until we reach the end of the file. In fact, there is a function that will tell us when we've reached the end of the file. So one thing you'll want to commit to your long-term memory is this acronym, EOF. This stands for end of file. So whenever you hear or see EOF, know that it means end of file. We want to replace our for loop with a while loop that continues while we haven't reached the end of the file. That way, no matter how many double values are in our file, we can process all of them because we'll process until we reach the end of the file. So let's go ahead and delete our code related to our for loop and replace it with a while loop. Now I said we want to process while we haven't reached the end of the file. And translating that English into code looks like this. While not input file .eof. EOF is a function. So in order to invoke or call the code related to that function, you've got to have open paren, close paren right after EOF. Now I run this and I do get my last value in the file, but I get that last value twice. That's kind of strange. The reason why we get the last value twice is we don't know if we've reached the end of the file until we go to try and read another value and there isn't another value to read. For example, after 300.03 has been read on line 34, we still haven't reached the end of the file. So this evaluates to true. Then we try to read another value, but the file cursor, and you could think about the file cursor just like a normal cursor that you'd have in a text editor like gedit. The file cursor is right here, right after the end. right after the last value in the file. And now you try to read another value and there is no value to read. So now we reach the end of the file, but this failed. So when we try to read out what value was just read in transaction, it's going to be what was already stored in transaction because there was no new transaction read that was overwriting the value currently in transaction. So let me try to type that up into notes so it makes a little bit more sense. So the above code fails, this line right here, when it tries to read a value from the file, but there are no more values to read because we've reached the end of the file. So transaction's not overwritten in that case. So it looks like the last value is read twice when it's really just printed twice. So in order to fix this, what you'll want to do is check to see if the stream extraction operation succeeded or not. And we can do that with a call to a function called good. So if input file dot good, then print out the value in transaction, else print out failed to read a transaction. And we won't print out the value in the variable transaction because it doesn't contain a new value that was read from the file. So let's save, compile, and run this. Now we just get 300.03 displayed one time, and we see failed to read a transaction. So everything makes a little bit more sense now. I want to make one last note about input file dot good. Okay, so .good checks only the most recent stream operation to see if it succeeded or not, which means you'll typically put an input file .good, like we have here, right after you do something with the file. For example, trying to extract a value. So here we tried to extract a value, so immediately afterwards we're going to check if it succeeded before we try to do anything with that value that was read. Just like when we were checking to see if the file was open or not, we should check to make sure the file was open before we try to use the file. Here, we should check to make sure that we read a value before we try to use the value. All right, now that we've successfully read values in from a file, let's go ahead and write values out to a file, which is just like using cout and the stream insertion operator. So let's go ahead and declare another variable, this one of type ofstream. We need to open our ofstream to the name of a file. Now we can put whatever we want here, a relative or an absolute path. Let's just use a relative path. And since we're kind of trying to emulate our transactionfun.cpp code we wrote a few videos ago, let's put in here average transaction.txt. So we'll just simply write the result, which is the average transaction, to this file instead of displaying it to the console. Remember, whenever we open a file, we should also close it. So good practice to just head right down here and close that file that we just opened. Now I think I can give you a task here. Go ahead and compute the average transaction. So the average transaction should be the average of all the floating point values in your transactions.txt file. We'll sync back up after you compute the average transaction, and together we'll write it to our average transaction.txt file. All right, so I've got the average transaction computed based on the total transaction and the number of transactions. One thing I want to emphasize, you'll want to figure out the number of transactions by counting the number of transactions read in your while loop. Don't hard code it to whatever value you know to be here. Like, for example, I know that there are 6 values here. I don't want to hard code num transactions to be 6 because that doesn't make our code very versatile or extensible. For example, if we were to add more values to this file, our average would be off, and it might be kind of difficult to debug that. So we definitely want to use the data in order to figure out how many transactions there are. This is called data-driven programming, where we're using the data to drive how we're going to write our code. All right. So as promised, I said that we would write this average transaction out to the file instead of to the console. All you have to do is change cout to be your ofstream variable, which is output file. That's it. Working with output files is just like working with cout. So I went ahead and ran this, do an ls, and I see there's a file here called average transaction.txt, and I'm going to cat that file, and I see 92.965 is in that file, which matches what I was displaying to the terminal for the average transaction, which is awesome. I can also open it up in gedit just to see it in another form. Another program. So we've learned a lot about working with files just in this video alone. We learned how to read values from a file one at a time. Then we learned how to wrap reading those values from a file one at a time into a loop that was run based on the number of values in the file. So that was very data-driven as well. Then we learned how to create an output file for writing values to a file on disk using an ofstream variable. We did that and found out that working with output files is just like working with cout. So everything we've learned with getting user input from cin and writing to user output using cout, we can use when working with files. ifstream like cin, ofstream like cout.